Looking at problems that have an inequality in them and how to solve them. X plus 3 is greater than 8, or is less than 8. So we're all the numbers of x that makes this statement true. Well, in solving linear inequalities, all the rules except for one apply that we did when we solved regular equalities. So the goal again is to combine all the like terms, then isolate the variable with the constants on the other side. So if I have x plus 3 is less than 8, I can subtract 3 from both sides. That's valid. I'm left with x is less than 5. So my solution is all values that are less than 5. There's different ways that I can report these solutions. One way to report the solution is called a set builder notation. And that basically states that all x such that x is less than 5. That is one way to communicate the solution. Since there's an infinite amount of numbers, you want to look for a cool way to communicate that. Another way to do that is through a number line. And I have 5 marked, and it's telling me all numbers less than 5. And so some people will shade that in. Because a number is less than but not equal to, I need to designate that 5 is not a solution, but every number below 5 is a solution. And we do that with a filled-in circle. And the last one notation that we use is called interval notation. And what it's saying is that I want all the solutions that represent here. Sorry, let me do that one a little bit better. So all the solutions are on the interval between negative infinity and 5. And again, since 5 is not a solution, we designate it with a soft bracket. And the negative infinity, since we can't pinpoint it down to a specific number, we also designate it as a negative or as a soft bracket. How that changes is that if we change the problem and made this x is less than or equal to 5, well, in this notation, it would change with an equal sign there. Here, we would either fill in the circle or put a hard bracket on there. And I guess the textbook uses a soft bracket for numbers that aren't inclusive. But we either put a filled-in circle or a hard bracket. Then likewise, how do I determine in the interval notation if its endpoint is a solution? Well, soft bracket indicates that it's not part of the solution. Here, if I used a hard bracket, that would indicate the endpoint is part of the solution. And as a reminder, infinity, negative infinity, or positive infinity can never have a hard bracket. There will always be soft brackets in interval notation. So there's 3 ways that you can communicate the solution. Please pay attention on which way is being asked for.